Today we're going to talk about the force of friction. Previously we talked about the force of gravity, which gave us this formula, mass times gravitational acceleration. And we talked about the normal force, which gave us a couple of formulas. So in the case where the object or person is on a flat surface, then it would be just equal to the negative of your gravitational force. And then if there was an angle associated, then you would include the cosine of that angle theta in your formula. So when we talk about friction, friction is the force that opposes motion. And it requires contact between two surfaces. That is the basic definition of the friction force. So, for instance, if we had a box that was being pushed along this way, the friction force would be moving in the opposite direction because the movement is going to the right, so the friction force would be going to the left. Now, friction is determined by the contact between these two surfaces. So if this was a block of ice and this was a surface of ice, there would be a very small amount of friction. This would be very small. Now if we had a block of wood on a wood surface, this is much more rough here, so your friction force would be significantly larger than this example right here. Friction force depends on the roughness between the two surfaces. It also depends on your normal force. So when we look at our formula, we're going to be having something that involves the texture, something that represents the texture of the two surfaces, and then our normal force. So, there are two types of friction. There is static friction, and then there is kinetic friction. Now, static friction occurs when there is no movement, and while this may sound a little counterintuitive, there is still a force being applied. So there's still a force applied, but this force is not strong enough to make the object move. So let's have an example. If we have a person who is let's draw that a little bit closer to that wall. So if we have a wall here, and we have a person doing the wall sit, gravity is pulling the person down, but this person is pushing into the wall. They're pushing into the wall, and as a result, they're using the friction between their back and the wall to prevent them from sliding down. So there is in fact a friction force. Now when we write this static friction, we're going to write F of S. So S is for static friction. Now the formula for this is F of S is equal to, well actually it's not really equal, it's less than or equal to what we call the coefficient of friction for static friction times your normal force. Now the reason this is less than or equal to is because you can be applying a certain force and you're not going to be moving an object. So for instance, if you're trying to push a fridge over top some tiles or over top gravel, something, and it's heavy, and you're pushing on it, but it's not enough to create it to move, you could be pushing a range of forces. You could push it 10 newtons, 20 newtons, 30 newtons, and that might not move it. You might only be able to move it if you pushed 100 newtons. So that's why we have this inequality here. Now, the maximum static friction force occurs when your static friction force is equal to your coefficient of static friction times your normal force. So this symbol here is called mu. It is the Greek letter in the alphabet, and this is your coefficient of friction. So I'm going to have a little side note here. So mu is the coefficient of friction. And this is the number that associates the texture of the surfaces, or the roughness of surfaces. So that's just a little side note for us. Now, kinetic friction involves movement, and the formula for that is F of K, K is for kinetic, is equal to the coefficient of kinetic friction times your normal force. Now, this coefficient is very different from this coefficient. When there's no movement, this is actually much higher than this one here. As soon as there's movement involved, then your coefficient of friction decreases. That's why we have the different values. We have the kinetic coefficient of friction and the static coefficient of friction. So these are our main formulas right here when we're looking at friction forces. So let's take a look at a couple of examples. So let's say we have a piano that weighs 120 newtons, and we want to know what is the max friction force that we can apply before it starts moving. And let's say that we give coefficient of static friction is equal to 0.6, let's say. So we have been given the weight. Now remember, the weight is the same thing as saying your force of gravity. Now remember that weight will have a direction. So when we give it this, we always have to make sure that there's a negative in front of it, right? Because gravity is pulling down. Weight, the word weight has a meaning. It means the force of gravity, but it also means that this value is negative. Our normal force then is therefore just positive 120 newtons. And we want to know what the force of static friction is. And we want to know what the max is. So we're just going to set it equal to our coefficient of static friction times the normal force. So 0.6 times 120. Once you put that into your calculator, 0.6 times 120, it should give you a friction force, a maximum friction force, static friction, of 72 newtons. So this is the force that is required to push the piano. This is the maximum force you can push the piano without it moving. All right, now let's try a different example. Let's say we're moving a fridge. that weighs 200 newtons. We want to know what the friction force is. When we know that the mu of K, so our coefficient of kinetic friction, is 0.7. So force of kinetic friction is equal to mu of K times the normal force. So 0.7 times 200 will give you a friction force of 140 newtons. Now, of course, you can have friction applying on an inclined plane, but we will take a look at that at a different day. Thank you for listening, and I'll see you guys next time.